So we would like to welcome Sumit Mundhada. Sumit is working as a test automation professional at Voice. With over a decade of experience in test automation, automation framework development, and quality assurance for cutting edge technology products, he's done an exceptional work as a tech speaker and blogger. He would be speaking on the topic optimizing software testing using artificial intelligence. To know more about Sumit and to see his video interview, kindly check the following link. Over to you, sir.
So, sir,
Thank you, sir.
I'll stop sharing my screen and you can take over the stage.
All right. Okay.
Okay, sir. Thank you.
Right. I'm just sharing my screen. Maybe you can confirm. Is it visible?
Yes, sir. It is visible.
And I hope I am audible. Like,
Yes, sir. Yes, sir. Loud and
Yes,
clear.
sir.
okay, perfect. Uh, Great afternoon, guys. I'm Sumit Mundhada, and my topic for the day is optimizing software testing using artificial intelligence. Before I go for an agenda, let me just jump to the agenda slide two, and then help you like exactly what we are gonna see today. I really want to touch base on something which is the key area and the use cases for artificial intelligence. But before doing that, from my learning, what I understood is like always it's like the artificial intelligence is wrongly interpreted. Maybe there is a fundamental gap of learning how does AI work. So we'll be starting with exactly what is artificial intelligence is a few minutes to help you understand how does AI actually works. Okay, then we will go on different machine learning approaches. You must have heard like what is supervised learning, unsupervised learning, but we will try to demystify like exactly how does it work. And the real agenda for all these three important section before we jump into the exciting part, which is of course the use cases, is to help you all understand in a very simpler way what is artificial intelligence. We do understand like within a 30-minute we cannot be master in AI, but my only intention here from this session is to simplify the things for you, so that you can rightly use AI whenever you get a chance. And believe me, there are plenty of use cases. I mean, it's not like these are the only use cases, but then I thought with our day-to-day job, whatever we are dealing with, I think this goes as some of the key areas, and already enough work has been done in those areas. So share with all of you, and then once you understand how AI works, right, I mean, then you can see, okay, what is my problem statement and how I can unfold my problem statement to different kind of a things and anticipate the timelines and things like that. Okay, so that's what the session is all for today. And also there are a lot of questions people generally ask, like how much programming do we need to do for AI and ML. I think I will take that in my slide for how does AI work, which will help you to understand that exactly when it comes to the programming and all, how much times you need to invest and really what happens when you work on those areas. Okay, uh, so I think let's start with what is artificial intelligence. Okay, and these are the definitions from the Wikipedia, of course, but I will try to help you in a very different way. Like artificial intelligence, we all know it is something which is demonstrated by machines as opposed to human intelligence, right? So this is just a broader terminology, or I would say this is what the domain is all about, right? So essentially, artificial intelligence is a terminology, a domain, and to perform the artificial intelligence it has to go with something which we call as a machine learning. Okay, generally people also call it is a subset from the artificial intelligence, where what you are doing is you have some kind of a algorithm, which basically you will be using algorithm of kind. I think probability is a very good example, like we all have learned in our college days, like what is the probability of throwing a coin and whether a head or tail will come. So that's a probability is like one of the formula we all know. Now that's a formula, but in machine learning those kind of things are evolved. The scientists have created so many machine learning algorithms for different practices, and this formulas essentially we are going to use on the data. And that's what the definition says, that you are going to do something automatically with the experience of using data rightly. So you have to feed the data, and then the algorithm will give you some kind of a desired result. But then comes a very important part, and I think the most core part, like which is a deep learning, another subset now to a machine learning, which says that here broadly we are trying to learn the things, based on the kind of a representation. Now it could be from the neural network, it could be from your NLP and things like that, but it is like another subset of machine learning, okay, and it learns based on the artificial neural networks is what the definition says. Now let's see very importantly, like how does AI work, okay? And on this particular slide, I'm just trying to help you. Just let me see if I can have a uh, mouse pointer over there so I can simplify the things. Now I'm not able to. I don't know if are you able to see the mouse, like which I'm.
Yes, Sumit, we can see it is hovering over data right now. We
Okay,
can.
perfect. Thank you, Harsh. Yeah. Okay, so that will help me because somehow it's not animation, but I know. Let's ignore and go with the mouse pointer, which I'm highlighting, guys. Okay. So essentially, there are three stages, for any artificial intelligence to work. Okay. And the most important stage is the first stage, which is we call as a data cleanup and the data processing. Okay. Now, pay attention here. Now, data could be of any format. It doesn't mean like you have to have a data like kind of a maybe uh, kind of an extraction of your, defect data or something like that. No, it's a data means the machine will understand data in the form of, again, the bits, but it could be in the category of either a text, it could be image, it could be your audio samples, like, so all these things goes as a, data for the AI. Now this data generally at the first stage, what the engineers does are like they take the data and they import this data into some kind of statistics which they can observe. I mean, one of the example like Power BI, many of us have seen, right? But not Power BI here. You consider like you are loading a data into the system, and after the loading a data, as is data, to be very precise, the as is data you are visualizing, like you are trying to see what data is showing, right? Now, example of kind, like, I mean, if you see a data like, how many are the toppers in terms of, 10th or 12th, and if we load that data and that data tells us that males and the females have the equal ratio, we can get some kind of an inference after loading a data, like this data is telling me this story, right? So that's the first part of the any AIML modeling, where the data is getting loaded and they see the data. And at the time, we often understand like data is not going to be have always a very clean data, right? And it is never, to be very precise, right? And also based on the problem statement, we have to work on the data to evolve the data so that ML I know model can understand those in a better way. Now, to do that, we do a lot of processing, right? And uh, you try to understand processing in this way. Like, I mean, the machine will not understand whether it is a male or a female. It can only understand based on whether it is one or zero, right? And that's what the story of data processing is, data science is, right? Now, what does this data scientist does, or the data processing engineer does, they take a data and they do a processing, right? They understand that if I'm loading a data, it has to be converted into something which machines can understand. And I think we all understand, machine will understand in the numbers, right? It will not understand with based on the name which you are giving to your column, right? So let's say you have extracted the data. Now that data says that, these are the members who are using the services, this kind of a services. These are the males, these are the females, this is the age group and all. But no, the machine doesn't understand with that string or the label. So it has to be converted into some kind of a formatting, which is the first step. And then a lot of problems will be there. Your data is not in the structure format. There is no a common, protocol set into the data. Your data is not balanced. Okay. Say example, you have a data which is only talking about XYZ area, but to create a machine learning model, you have to have data from all the categories, right? Because otherwise it will be a biased predictions, right? So this kind of a things happens into the data processing, okay? And that is the most important time where the data gets converted into such a way which can be used for further processing, right? And now here the most important thing comes, which is splitting the data, right? Now what happens, let's say I have a data and I'm just saying as a number, like I have 100 records which I have filtered, which I have cleaned up, which I know now I can easily fit into the machine learning model. I'm just taking a pause here because you might be wondering why Sumit is saying like take a data and now feed it into the model. Because initially that question was also to me, but I understood by learning like the ML models are already ready. They are just waiting for the formatting of the data, and it's not like new things we are creating. It's already there, right? And that's why this data processing is happening, because they understand how the ML work. You will also see like how ML work and how ML works is going to decide how data processing is going to happen or the data structuring is going to be happen, right? And here, these all things are happening. Once your data is clean up, it is ready, then you split the data, right? Now, a very simple thing, why you split the data, why you are dividing your data into training and testing data. And guys, like this is a very complex topic. I'm trying to simplify the thing so that we all can understand the journey, how it happens, and then you can relate whenever you're dealing with any kind of AML, use cases, right? So here what happens when you split the data into two categories, your objective is I have 100 records. Going back to the same example, I have 100 records, and out of 100 records, 80 records I am going to feed to the machine learning algorithm. And then I'm going to see what output machine learning algorithm is giving back to me on those remaining 20, right? So I have 100 records, 80 I am using for training the machine learning models, okay? And after that, I am verifying those machine learning models on the remaining 20 set, because that is not a hidden data. That is a real data, which I know that this is the output. The moment the output goes with the same data which I already have, I know my predictions are perfect. My model is ready, right? And that's a very important part. Like you cannot just give a data and ML engineers are going to provide you the models. They are going to try and test them. Sorry if anyone is speaking, if you can go on mute. Thank you. I hope I am not on mute. Harsh or Jyoti, if you are here.
Yes, we can hear you, Sumit.
Okay, perfect. Thank you. So now, what I was trying to say, like you have splitted the data. Now, when you have splitted the data, this remaining data you are trying testing on the real data which you know. And when you are happy with the predictions, then you will go and deploy model into the production, right? And then you will start from there. I think it's the ready things, and then you will start utilizing it, monitoring it, and doing the analysis. Now here I will take a pause just to help you understand one important factor. Now, when you are going to decide like model is ready, right? It's a very simple answer. Like you are going to decide based on the problem statement. Like for example, if I have to create a prediction model to detect whether a person uh, is going to have, maybe cancer or not. Now, this is something very important problem statement. So I cannot have a prediction of 70 or 80. Like I have to have a almost 100% prediction accuracy. But if we turn the case into something which is about, let's say, customer churning, I want to understand whether this particular, person is going to leave, or maybe, we are operator and I want to see whether it's going to leave my services or not. And even if it gives me 70 to 80, I can understand like these are the potential areas where I need to, come up with some kind of, offer or something like that. So based on the problem statement, you are going to decide whether the model is ready or not, and that's why this arrow is there. And then if everything is good, then you're going to have that into the deployment. So that's all about how does AI works. I think that's a journey. And now I will take a part of different approaches what happens in machine learning algorithm. So the first thing is the supervised learning. Now broadly machine learning approaches are divided into three categories, and this is what we are looking in this particular slide is. Now what happens in the supervised learning is you get a I mean, I'm not going into a definition, I'm just trying to help you, like then you can relate every time whether your problem statement is going to sit into the supervised learning category or some other, which we have not seen. But just to help you, like if your output is known, you know what you want, okay? Any use cases which you have, just ask this question: do I know what I want? If you know I want this from the use case, then that goes to the supervised learning, right? Because your output is already known. Now the example of kind would be like you want to understand, I think I have that example also, like weather forecast, right? We are clear what we want. We want to know whether on a particular day there will be rain or not. So we know what we want, and the moment we know this kind of a use cases, they goes into the supervised learning. So that's a very a simple concept, guys. Too many complexity are there, but I'm trying to bring you in a very easier way. The best way I can bring it to you is if you know your output, you are into the supervised learning, okay? And then supervised learning works into two categories. It could be a regression or a classification, because regression means you are having a linear, input output, and you want to derive something. Classification means you want to understand, a particular segment of the market. I think the example like stock market forecast or something, right? Or maybe a data classification. You have, let's say, images. You want to classify the data, like whether these images are for kids or these are for elderly person or not. So kind of a classification if you want to do, or a kind of a regression you want to do, you will land up into the supervised learning. Now, one more important part here is to remember, do you have a label data? Okay, if you have a label data, now what label data means, like you have your parameters known x, y, z, and you know why. Okay, so you have a very clear information what this data is talking about, right? So I think most of the problem statement goes where we know the data, we know the out, we know what we want, and then it becomes very easy for us to land up into the into the domain of supervised learning. So that is the supervised learning, where now essentially now you can relate like it is a supervision, right? Because we know what we want, we know our data, and we are doing a supervision to understand, is it going to provide us those kind of predictions or not. So that's a very simple way supervised learning. We are spending time here now because use cases everyone can talk, you can get on the internet, but now you will understand your use cases and then where it is going to fit in your organization or in your work, whatever you want to do, right? The next is unsupervised learning. Now, this is an example of the thing where you don't know what you want, right? So it is like you are flooded up with the data. Okay. Now you want to learn from the data. Okay. So data will be fed into the system. Okay. And then from that feeding of the data, you want to understand with the base on the basis of structures and the patterns, like which category it can go, right? So here, what you're essentially doing is you're feeding the data. You don't know what you want to get from the data, but then data is going to give you some kind of inference, some kind of an information back based on the structure or pattern they are going to do. Kind of things like clustering, association. Like you don't know what you want. You have fed the data, and data is giving you some kind of an output. Like, you know what? These are the association we see. Like these are the group or these are the clustering we see, and then this data is giving me this kind of an information, and then with that information I can build something, say example market segmentation, or say example feature engineering. You want to understand what are the hidden things this data is giving back to me, and then come up with the solution. This is not going to fit into the directly into the supervised learning problem statement, but something where, say example, into the space, we are trying to see whether a planet is there or not, because we have a data, but we don't know what exactly we are going to see. So these kind of things are going into the unsupervised, because we are feeding a system into the unsupervised mode. We have a data, whatever we were having, and then we are trying to understand the pattern and the structure, and then bring some kind of inference out of that. So that's the unsupervised learning. And then comes very interesting, the reinforcement learning. Will not go into that detail, but again, like I think the very good example, like a robot, right? Or maybe a dog, a robot dog. Let's say scientists want a dog to learn, or maybe to jump from the building, right? Now, there could be a situation like I cannot do completely supervision and unsupervision. Now I want to start something different. So that's a deep learning, where what you are doing is a very simple way. You are doing a reward and a punishment. So if a dog is behaving right the way you want, or the way it is learning, and I think in so many series and movies also we have seen, then it is giving a reward. You are getting a reward that you did brilliant. If not, then there is a punishment, and from that punishment the dog will understand next time that, okay, I don't want to do that. Okay, and then learn from again that data, because that output is again a data, feed it back to the system. Okay, and then again the learning is starting. So that's a reinforcement learning, and then automatically, one day fine day, the dog will jump, and you will say that, okay, it's learned. So training is happening based on the reward and the punishment. Okay, and then the algorithms are different. And I think we know about autonomous driving, like you want to drive safely the cars and the games, right? The another person is playing with you. Okay, so those kind of examples will go into the reinforcement learning. Now, something which I just want to bring onto the slide, but you don't need to take pen of it. But this is just to help you or give you a glimpse, like which are the algorithms are there. So logistic, KNN, SVD, PCA. So these the right side things are the algorithms which basically you gonna use in this. And I have purposefully added this thing here just to help you guys that these algorithms are ready. Okay, so there was a question like, in fact, before the event, now people were asking like, okay, AIML, like how much programming we need to do. So you need to do the things which are already the set up the things like data processing, data cleanup, and already there are things written, right? So you're not going to start something from the scratch. This is the process. You have to bring data into that particular format. So till that time there is a coding. After that, data is directly going to fit into the ML. So it is like a library, right? For I don't like if there is any automation engineer or programmer, right? So we are importing the libraries, okay, and then we are using those functions. So similarly here, you have a set of libraries ready, and then the algorithms are ready. You are going to import the algorithms into your programming, and then the data is going to fit into the programming, and it is going to give you a result. Probability you are not inventing. You have a formula. The formula will feed the data to inputs, head and tail, and will give an output, right? So that complex part is already ready. The algorithms are ready. Here we are doing data processing, cleanup activity, and going further down. So that's the programming aspect also, which I just wanted to bring. I think brilliant. After that, I think the use cases are pretty simple. I think I have here few for to help everyone. Which things you can start? I think the most important in automation we often see about AI-based locator strategy, self-healing of the automation or smart locator assistant. A lot of tool, commercial, open source few libraries are there which does this job. How they do, you can understand there is a pattern, right? Now there is a data, there is a DOM object model, the pages are there, right? So these are getting feed into the systems, and then the predictions will come, okay? And the most important use cases really which we have seen in the recent year is assistant to the automation engineer, because automation engineers can write the code, but whether this particular XPath are robust or not, that kind of a precision or a prediction can come from the AI based locator strategies, right? And a lot of plugin tools are ready. I really don't want to go into the tools. I just want to help you, like this is the information, and now you go and see based on your use cases, and you know how AI work, where you want to fit your use cases. Predictive analytics, a very initial stage. We have seen about data analytics, right? Data cleanup and all. Here, this problem statement fits. You have a data, you have fed it into the system, and from that data, you want to bring some kind of a inference out, right? So, for example, you have a defect data you have added into the system, you want to understand. And now, again, as I mentioned, there could be different use cases. If I want defect prediction, it is kind of a linear regression program. If I want defect classification, it's the clustering, right? I want to see defects are coming in which categories, right? So this is a classification problem, right? That's why I have spent time to help you understand what are those approaches, and then see your use cases and fit, and then you will get a desired result. Otherwise, often we do a mistake in the initial stage before knowing how AI/ML works, right? Smart test suite. I think there was a very interesting session also. Like I understood about how AI/ML can help you with the data, which test cases to be selected in your automation, a kind of a advancement to the risk-based testing, I would say. Smart test suite selection, AI-based test planning, definitely, like this is already there in the software. From the data, they give you some kind of planning and the statistics. Um, a very interesting something, AI based fuzz testing. If you don't know like what is fuzzing, it is like you're trying to put some kind of wrong things into the system, like a malicious code, or maybe non required or the wrong inputs into the system, and then you're trying to see how the system is behaving, right? A kind of a security vulnerability testing and all. And it happens generally in very automated way, because it's a heavy consuming in terms of manpower or processing. And that's why AI based first testing is now coming back, where people are trying to use a lot of AI, so that from the data they can learn which kind of a vulnerability or which kind of a wrong input to feed into the system, and find uncover hidden errors into the coding, okay? And then visual testing, I will really not take this time, because I have seen like a lot of people now already understood one of the concept, computer vision. That is also one of the machine learning algorithm. Now if you want to understand, so that's simple thing is it is. And in the computer vision, you are trying to use the images, okay? You are trying to use images, and then maybe someone wants to understand whether this image goes in which area, or maybe someone wants to understand whether there is any visual testing defect or not. So it's a visual comparison, but essentially happening via a computer vision domain algorithm and the set, okay? Now, speech recognition is something you cannot test everything, and here the NLP deep learning algorithms comes into the picture. Example of find call center testing. You want to do a call, you want to use a bots and understand whether the proper responses are coming or not. So that's a proper speech recognition use cases, which will go into the deep learning set of NLP, and then you are going to find out the desired result based on that, okay? Um, this is very interesting. I really want to take a minute on this NLP, like natural language processing use cases. And I think I have just kept here two because there are plenty, as I mentioned before also, but two important, like NLP for creating the test cases. Like we all know about model-based testing, and the advancement happening into the model-based testing is all about AI, right? So they want to have a logical, cognitive intelligence, so that from the data patterns and particularly into the domain of microservices, how we can create the test cases and the hidden scenarios. And then second is NLP based test automation. I have not used the very complex terminology here, but NLP based test automation means you will often sooner see advancement to the BDT, right? We all know BDT, like a very like you use a simple English, you write the code into that format, in the backend code get generated, right? But now when you have a capability of NLP, the things are coming into into the market, and it's going to be there definitely. Is like going to be having an AI based BDD and the advancement, where people can write code in simple English. There are plenty tools into the market who are claiming like they can users can write code into simple English, like I want to log into the Facebook, I want to verify this, and it will be converted into the code, and this will go back to your use cases or the design document. So directly from there you will be getting your automation suite ready. That's a very interesting. If you get a time, please go and see like how NLP based test automation is happening, and which are the tools and what different features they are claiming. Okay. uh, I'm just trying to use the word like advancement to traditional BDD. Now, AI-based API testing, a very important subject, guys. Again, like understanding, again, it's a relation, right? We understood in some kind of unsupervised learning where we want to understand the pattern, right? So I think API testing is mostly that area, and I think information is also not readily available. So if we feed ML models which are ready, who can understand the pattern, they can do sort of reasoning. I think AI-based API automation is going to be the future, where, of course, AI-based testing is already there, but AI-based validation, AI-based assertion, development, and understanding the complex behavior between the microservices, because we cannot be expert in everything. And here, the patterns can really come from to us based on the modeling which ML can do. Okay. And then autonomous testing. I really wanted this word to be like from automation to autonomous testing, but I'm just keeping like this autonomous testing. What I mean to say here is creating test cases, autonomously. Having said, when we understood this is a capability, right? So the future lies into the autonomous testing, where we are trying to see the data, the pattern, and then that pattern will tell us like which kind of a user interventions are going to happen, which kind of a use cases are going to required. And then of course, based on the NLP processing, which we have seen, if we club both of this together, then this pattern recognition based on the data will lead us to have automated test case also created. And few tools are almost claiming that too. So yeah, I think that's all about the use cases. I think I am almost on time, or maybe uh, if I have shooted the time, I don't know, Harsh, Jyoti, if you are there, but yeah, I'm open for the question and answer if any. Hello.
Yeah, sir. Sir, actually, I had a
So,
question.
Okay,
Yes, ma'am, please
please.
continue.
yeah, you can go ahead. I
Okay.
will ask it.
Okay. So, sir, if someone wants to pursue their career in machine learning, so
Mhm.
is it very mandatory to be full frank with the data analytics part?
Okay. That's a good question, because see, end of the day, machine learning, if you want to be expert into the machine learning, I think we have seen one slide. I will just quickly go back on how does AI works. I think that will help you. I was spending a lot of time here to help you. And I think after explaining data processing, I have just taken few seconds to help you on machine learning. Even I have not spoken about deployment, right?
Yes,
Why I
sir.
was taking time there, because if I don't know how ML works, I don't know how to process my data, right? Because if I know the machine learning algorithms are these and they are limited, okay? So if I know these are the machine learning algorithm, every algorithm works like this. My problem statement sits into this kind of a family of the AIML, like supervised learning, unsupervised, reinforced. Now the picture is very clear to me. Like the data processing will be inclined to that kind of a model, because I know these models are going to take my data and process it, right? So, but but just to help you on that question, it generally doesn't work. Like one person cannot do all this activity, right? So when it comes to the category of the career and all, right? So data scientists are different people, operational people are different, AML are a different stream, right? So there is a team who will be doing data processing, feeding back those information to AML engineers. Both these teams together are going to work with the operational teams or the business teams, and then of course the technical deployment team will come in the picture. Here also, the pipeline, everything is like that only, which you see in your software testing or DevOps.
Yes, sir. Thank you so much, sir.
Okay.
Jyoti ma'am, you were saying something.
Sumit, while in this conversation itself, you're saying about machine learning algorithms. Can you name few of the algorithms?
Yeah, logistic, KNN and all. I think all these, Jyoti, I've just added here, like these are the algorithm: logistic regression, KNN, SVD, PCA, DQ and DDPG. So these algorithms are all already there, and not only for you, Jyoti, for everyone.
Right.
That's what the point I was trying to make. If you want to, help that in a broader spectrum, these algorithms you guys are not writing. Okay, these algorithms are ready. These are like the libraries are readily available for you. Okay, there are tools available who can import this thing for you as a programming. Once your data is ready, you feed that to this algorithm and they will give you the result. Okay, and for every category like supervised, unsupervised, reinforcement, these are the algorithm, but these are not limited. These are just for an example, because I wanted to have that flavor to into the presentation. You will get a lot of those kind of a direct cheat sheet, like category of the machine learning and which algorithms are available for them. Okay, so yeah.
Okay. Now, just a refinement on this question. Looking at this algorithm, which is more significant algorithm from testing point of view? If I want to do something, no.
Great. Okay. Very good question and a very simple answer. No algorithm is perfect. I will go back to this slide and I will try again to come to this particular point, right? So, thank you, Jyoti, for bringing that question. If I have missed, when I say you are feeding this to a machine learning algorithm, essentially there are plenty of algorithms. So supervised learning have, let's say, 8-10 algorithms ready. Okay, so all those 8 and 10 algorithm will be tried and tested, and generally it happens in the very initial time when you are not expert, but generally after time, this kind of a problem statement will deal with these two algorithms. These are really good, and then you will see output from all those algorithms, and then one particular machine learning algorithm you will be deciding at end, right? So here, for example, I'm just taking supervised learning. We have logistic, regression, KNN, and there are plenty, right? So we have used clean data and just seen the output from logistic regression. If it is giving me the result, and there are formulas for everyone, there are few categories, 4 5 pointers like accuracy, I think they talk about some kind of a matrix that gives you all those 4 parameters, and then you can understand, okay, this model, this is giving me, this algorithm is giving me this kind of accuracy prediction, this kind of algorithm is giving me this, and then it is on you which one to use for your deployment, right? And then that tells, like, you don't need to learn about this algorithm, you just need to use them, right? So you will be in this stage, you will be using a plenty of algorithm, and then you will be deciding one algorithm which is suiting your purpose, and with that algorithm you are going to the deployment. If I answer your question, Jyoti.
Yeah. So just an additional question, maybe.
Yeah, please go ahead.
I'm not troubling you.
No.
So while you said like we have just implemented all, whatever the implementation is, one of the algorithm is finalized and we are getting data. So what I see here is, correct me if I'm wrong, maybe I'm just trying to test my understanding here. The API testing would hold more significance, like in order to test these algorithms, whether the formulas are applied correctly or not, whether the output or the data which we want to process is what you can say, changed or not, right? Is this understanding correct?
But I think your question is still on that. Like, I mean, just to rephrase your question, Jyoti, if I'm wrong, you're trying to say that when it comes to algorithm, are we going to try the algorithms and again we are going back to data to filter or process the data? Is that the question?
No.
Okay.
This is not my question. Maybe this is more about understanding. Like, so since I am a QA professional, I really want to detect how I am going to test all this implementation.
Oh, okay. So on the testing data set, Jyoti. So okay, I will just quickly help you on this part. Okay,
Mhm.
a very core subject, and that's why I have spent a lot of time here. But good question. Thanks for bringing that. What happens here is when you have, let's say, 100 data. Okay, you have 80 data. You are first you are doing a cleanup activity, like, and there are plenty of stages to that. Once it is done, then you are feeding those 80 records to machine learning algorithm, and there are 4 5 algorithms, say example for your category or the use case. Okay, then those 80 records on those 4 5 you will be testing, they will be giving you the result. They will be giving you result on what? Now that's the question. On the testing data. So you have already known that in the last month, say example, I got this many defects. Okay, but you're not giving that information to the system, to the algorithm. You're checking whether the algorithm is giving you the right result or not, and you have already that data with you. Then you are doing a comparison. Oh, I got this in the last month. Now ML is also providing the same. That means the model is ready for the next month deployment. Okay, so the splitting of the data also happens in this stage, and on the remaining delta of the data, we guys are experimenting the machine learning model, because we know if the model is saying X, we already know what is X, and we are trying to compare with that. And that's how we decide the model is ready or not, and then we go to the next stage, okay, which is a real data. So here, if you see the word real data, this is not this data which is coming from the history.
Right. Got it. Got it.
Yeah.
Sumit, I'll catch you up later, I guess.
Of course, yeah.
We
Right.
just have a time crunch, and maybe we can move to.
Yeah, I know it's a complex subject, but I will try to help.
Complex subject.
Even if there are other questions, connect with me on LinkedIn, or if you can get my number from the event team and all, and I will be more than happy to answer this question, and also share some of the use cases which I did in my learning time, and share if you want to get some kind of inference from there. Okay.
Sure. Sure. Thanks, Sumit.
Yeah. Thank you.
Yeah.
Alankrit, maybe you can take it out from here.
So thank you so much, sir, for an interactive session. I would request